Hello, everyone, and welcome to today's webinar, From Machine Data to Space-Aware Reasoning, How Unified Locating Creates the Common Language for Physical AI. First, a little bit about AIM. AIM is the Industry Association for Automatic Identification and Data Capture Technologies. We serve as a hub for quality resources covering all types of barcode, RFID, and mobile computing information. We also foster new auto ID innovations that stimulate market growth. We encourage you to get involved. If you would like additional information, you can reach out to us at info@aimglobal.org. And then I would like to quickly go over AIM's antitrust policy. It is the policy of AIM to conduct its operations in strict compliance with the antitrust laws. No AIM activity shall create even the appearance of a violation of the letter or spirit of the antitrust laws. And then just a few other housekeeping notes. All registrants are muted upon entering the webinar, but we still want you to participate. To send a question, you can select the Q&A icon at the bottom of the screen, and we'll get to as many questions as possible at the end of the presentation. Also, a recording of the webinar will be available in the coming days to those that have registered. And today we are joined by leaders from AIM, Profibus and Profinet International with Omlox, and the OPC Foundation, organizations that are jointly shaping one of the most important foundations for the future of industrial AI. Industrial environments already generate enormous amounts of machine data, PLC events, robot telemetry, machine alarms, MES transactions, vision detections, and sensor streams. Yet one critical dimension is often still missing, and that is space. Systems may know that a machine stopped, a pallet was scanned, or a robot changed state, without understanding where this happened, relative to what, inside which process zone, and what should happen next. Autonomous decision-making remains limited. And that is exactly why today's discussion matters. So today we will explore how unified locating, interoperable semantics, and a common spatial language are becoming the foundation for physical AI, robotics orchestration, and truly autonomous industrial systems. So Peter, I will turn it over to you to frame why this collaboration between AIM, Omlox, and OPC Foundation is so important at this time.
Yeah, thank you, Bethany, for introduction. And hello, everybody. Thank you for joining our webinar today on global positioning. So some years ago, it was exactly 2023, AIM and Omlox and OPC Foundation decided to create a common working group on global positioning, or to say it in other words, beyond real-time locating systems. And it was based on the idea of combining ID issues with real-time locating issues. And this was driven by automation and creating more and more autonomous processes. And so it was parallel with the rise and development of markets for RTLS systems and beyond. So this was in a very brief, this working group started, as mentioned, 2023, and it finished its first step work last year in autumn. And the results of this we try to present today. So that's in a very brief about the history and about the necessity of this format. Thank you very much.
Thank you, Peter. And before we dive deeper, I wanted to give our panelists the opportunity to briefly introduce themselves and explain why this challenge is so relevant from their organization's perspective. So Matthias, we will start with you.
Yeah, thanks, Bethany. So my name is Matthias. I'm a committee leader for the Omlox Technology Group. Profibus is an industrial automation association with 800 members globally. We deal a lot of stuff regarding OT-related topics, machine communication. We have a robots working group and a working group dealing with locating things that are moving on the shop floor in logistics, geoinformatics, and I'm passionate about finding things, and that's the reason why I'm a volunteer to be committee leader in this technology.
All right, and then Olaf will go with you next.
Yeah, thank you. Well, also a warm welcome from my side. Yeah, Olaf, my name is Olaf Wilmsmeyer. I'm the owner and founder of Wilmsmeyer Solutions, but I'm also the delegate for standard regulation from AIM Europe. And I was one of the initiators already of the Auto ID Companion Specification for OPC UA years ago. So this was a bit the starting point. with this kind of thinking, and to think about how to also include as well RTLS in such a description and in such an technology. That's briefly about me.
Okay, and Stefan?
Yeah, first of all, thanks for having me here today. I'm representing the OPC Foundation with more than 1,000 members across the world. And what this community is doing is a standard called OPC UA, Unified Architecture, which I can explain just shortly. It is not a protocol to exchange information. It is exactly not like that. It offers three topics. Number one, it's a modeling language to describe things and services and their behavior. Number two, it has integrated transport for multiple layers with multiple requirements. And third, it has built-in security by design. Because if something is not cyber secure today, all the rest has no value, right? And so, first of all, here, my congrats to all the other three players, because they are the real heroes using our technology, but bringing it down to earth with additional value. And from my point of view, this value is that there are a lot of areas in the world where you need positioning, right? And people might think about immediately on mobile robots or whatever, but it's in many more cases where you need the position of something to interact with each other. And now think about every of these ecosystems would use their own description for the position and their own digitalization standard. This would result into super high efforts for integration. And so we all, the world, has to agree on one model, to agree on one description of something. What does a position mean and how to find this? And that's why I'm super proud to work with all these people here, with these smart people, that we all already agreed on one standard, which is accepted worldwide around the world and can be used in multiple areas. Because what I like here with all these colleagues here is we all have understood that one association on its own cannot solve the challenges of the world. We have to work together in the best meaning for all of our members, right? Yeah, thanks.
All right, and then Peter, do you want to give an introduction from AIM Germany's perspective?
Yeah, so thank you very much. So I already tried to explain a little bit about the initiative. So my name is Peter Altes, and I'm responsible for AIM DACH, which means AIM German-speaking markets, Germany, Austria, Switzerland. And we are around about 100 members in a moment. And we are working to add some remarks on Olaf. We are working since 2014 together with the OPC Foundation. And since more than 5 years, we are working with Omlogs. And I'm very happy that, as Stefan already mentioned, that we benefit from cooperation instead of competition. And we hope that we can show this in this webinar. So that's for the moment, Peter, AIM, Germany. Danke.
All right, so we are going to start with the core problem. Across industries, we still see machine data, identification systems, locating systems, robot maps, and digital twins often living in disconnected silos. So what specifically led to the formation of the GPos Experts Group, and why was now the right time? And Stefan, we will start from the OPC Foundation perspective.
Yeah, I think I gave the answer already before but I can summarize quickly. We all have to agree on what does a position mean, outside, inside, and that's why we all need to agree on one modeling language, that we have the same meaning, the same understanding of what we have described, and that's why I'm super thankful here for everybody on this call here, agreeing on this OPC Foundation as a digitalization standard around the world, which has been accepted by the industry. It's driven by the industry, and it belongs to nobody, and so it has a really good position, and yeah, most important, it has security, cyber security built in by design. So we have agreed on this, and all the specs can be used already, and this is the great success of this challenge we have addressed before, right? Yeah.
Thank you. And Olaf, from the AIM and RTLS side, do you see the same fragmentation in customer projects?
Yeah, as Stefan already mentioned, I guess it is very important that you have the same meaning or same understanding of information which is provided. Otherwise, it's not really information. Yeah, it's just the data. And when we started together with the OPC Foundation in 2013-14 with the specification of the companion specification for Auto ID devices. Of course, RTLS was a part of it. And that means we already started to think about, well, how to define, how to describe, how to hand over the information of a location, of the location. I mean, which is core information when we're talking about real-time location systems. Yeah. But we have seen already at this time that there is still a gap. It's not 100% done. And especially when we're talking about different kind of technologies. So already the companion specification for Auto ID devices, the goal was to have a vendor and technology independent description of how to get data, how to interpret data. That was the goal. I guess we achieved very well with this, but again, the part RTLS, especially the description of the location, there was a gap. We need to understand that RTLS is not based on a single technology. So we have multiple different technologies and also multiple vendors, of course, which are offering such a solution and devices for it. And often we see in reality that we have a combination of different kind of technologies. So because of this, it is very important to have a common description, a common understanding of the information and especially about the location system. So that was the motivation from AIM perspective to start this collaboration and to describe in the end what we did in our definition.
Thank you. And Matthias, when an autonomous forklifts, AMRs, and humans share the same workspace, what happens if there is not a common spatial language?
From Omlox, we took a different route. When we started dealing with locating, we collected 200 something use cases where location data is relevant. Some of them had been around autonomous material flow, and of course, use cases like asset tracking, tool tracking, worker safety. And back then, we, as Olaf mentioned, encountered, there are so many technologies that can provide locating. We have to have a concept to fusion location data from vision to an RFID-based locating or an ultra wideband-based locating. That was our angle. And then we encountered, okay, we are in almost we have solved this locating topic, but how to identify things that we have located, and then we encounter we have to work with AIM on identification and all these kind of topics. And the next step when we also approached OPC, we said, okay, we have locating, but we have not the semantics of a machine or an input of a sensor data, and where is this located? And that so we came from a different angle, but surprisingly, all the three elements of OPC and AIM and us fit very nicely together. And that was our perspective on we thought common understanding of positioning is needed. And as we all know, auto positioning, we have GPS, and in normal situations, we have positioning data available at hand in our smartphone. But when you go indoors, so then it becomes a different story. And that is exactly the challenge that we are facing and that we have solved with the three associations in a combined approach.
Thank you. And so what I'm hearing is that the real challenge was no longer data generation, but it was shared machine readable context across space, identity, and process semantics, which leads us to the next section of this webinar. Before we get further into our discussion, I would like to take some time to define the key terms because many people use RTLS, spatial intelligence, and physical AI almost interchangeably, which they are related, but they are not the same. So Olaf, could you start by grounding us in RTLS technologies and what they fundamentally provide, please?
Yeah, so, well, I do my very best. Yeah, as the name already pointed out, it's about real-time location systems. So that means it's a system which tries to get the location of an item, typically items which are somehow in movement, but it is really hardly related to the use case, especially when it comes to real time. I mean, there's a totally different story if you're talking about forklift driving through a production hall or if you're doing pallet tracking. Sometimes, of course, a pallet would be on the forklift, but sometimes if the pallet is just somewhere stored and pretty fixed, or if you're doing maybe machinery tool tracking in an industrial application, also here, when the machinery tool is on a machinery for a couple of hours, of course, real time is totally different, specified, I would say, when talking about autonomous driving vehicles, yeah, which needs to react directly. And that means in milliseconds, maybe even, or minimum in some 100 milliseconds to react in the right way. So because of this, again, real-time location system is about really a system which gives you the location of a system. What real-time means is hardly related to the use case, but I guess a very important a kind of base technology nowadays, and it could be fulfilled with a variety of technologies. So we already heard about UBB, 5G, maybe Wi-Fi systems. Also, RFID is in use to get the location of an item. It really depends on the use case and how the term real time is specified. I mean, maybe it's also enough if you know that an item is in a storage area or an item is at the machinery and so on. Yeah. So that is what we're talking about when we are talking about RTLS. Of course, also vision systems can be included. Now, not just the classic technologies I already mentioned. Of course, nowadays also more and more vision systems are included to fulfill real-time location system. And that brings us very close as well to the topic AI. So that's maybe the bridge then also to the rest of the story. Yeah, as already mentioned earlier, in the end, we're talking here about base technologies, base technology. And because of this, it's very important if we're talking about base technology that the base technology can be integrated seamlessly into full solutions and is clearly standardized so that it is an easy way to use and to participate on the technologies. So I guess that is very important, and that was also our motivation to go in this direction.
Thank you, Olaf. That's a great foundation for us to continue building the conversation on. So, Matthias, I'm going to switch this to you. This is exactly where the conversation becomes more strategic. When does locating become spatial intelligence?
Collecting movements from an RTLS, vendor independent, technology independent, is the foundation. So you get a data stream of X, Y, Z positions, either indoors in the local coordinate systems or outdoors via GPS coordinates. But of course, that does not relate to a business process. And therefore, you need to have also some kind of semantics. What does a movement mean? And in that context, quite often in a business process, you have an area, for example, where you want to know that a certain item is in or out in a warehouse, or a person in a dangerous area, or a truck arriving at a yard, so that you relate the movement to some kind of spatial semantics. And that, if you encounter those spatial semantics, can then trigger an ERP system or an alarm that a person is in danger, or a transaction that parcel is delivered and the payment should be executed. So translating movement via different technologies to business-related events that would refer to kind of spatial intelligence. And of course, if you collect all of this kind of data, then you can also understand how much space do I use, where are congestions in my business process, where there might be dangerous situation because two things coming close to each other. So you understand, as that, the physical pattern of your business operation. That is a foundation, of course, to then optimize and use then, of course, Olaf mentioned it, the data stream and the collected data with the semantics to fuel AI systems to reveal patterns that are not obvious, for example.
So continuing on with that conversation, a few questions that I have for you are, how do coordinates become meaning, and when does a location update become an operational decision?
Yeah, that depends strongly on the business process. For example, if a tiny object is moving along a conveyor belt, that might be not relevant. But for example, if it drops the conveyor belt, that it becomes relevant. So not every movement, it has a certain relevance for your business process, and therefore you need to map your business process to the underlying locating technology, and that is what we, for example, in Omnos allows you to do, and then add data from auto ID technologies or machine data. So the combination that gives you then the intelligence and helps you to identify this movement is relevant for my business process, and this one might just be another data point and not relevant.
And so how does this change AI reasoning?
Today, AI is quite, if you speak about physical AI. So we have, of course, large language models that are trained on text and descriptions and things how mankind or humans have observed the world and put it down in word, in images, in videos. Now there is a great shift going on in order to achieve a even more intelligent system, that systems try to learn from the world itself. And quite often they are doing this vision-based systems, like us when we have been a child, we have been observing and watching our parents and watching some things falling down, and then recognize, oh, if I drop something, it falls down. Then there is something like gravity. But of course, not every thing in the global or in the world can be observed by vision. That is where a locating system can and the means to observe the world and extend the capabilities to capture what is happening and use this kind of data stream to train AI models, world models, physical AI models, train robots. They have an even better spatial understandings and also understand relations of things between each other, spatial relations, what is left, what is right, how things are moving. And we are doing here in this joint working group, we provide another data stream for any physical.
And so then I think this finally leads us to physical AI. And Matthias, how do you define physical AI in the context of industrial automation and robotics?
Yeah, so today, of course, a lot of buzz is around robotics, humanoid robotics, and things that are machines that have the shape like us humans and that interact in the real world. On the other hand, one can consider production site as a huge robot. And we have a lot of machinery installed that might not move, but has a certain place. We have fields going in and going out, being transformed by other machines from raw materials to good. So one can consider sites, floors, huge machines. And there, OPC, of course, is strong, getting data from all these tiny elements within this huge machine. And therefore, in our context, we consider the term physical AI a bit broader than at the moment done in media, not only just by humanoid robots, but in a bigger context. So everything that relates to industrial automation and combined machine data, whether it's stationary or movement or material handling equipment, all of those can be considered as physical AI application. And of course, companies or managers dream of a dark factory, humans in the loop. It can go run day and night without intervention. And that might be a future that might happen or not, but at least the direction is more into automation, more into AI, embedding into machines, and therefore we consider physical AI not only as mobile robots, but in a broader context, and that is where AIM, a strong sense on identification of things that are in production or that are in transit or that are in the warehouse. At OPC, strong in all the machine data that is gathered and collected. We from Omlox and Profinet with a locating aspect have a clue code or clue element between auto ID and machine data.
Thank you. And would it be fair to say that physical AI requires systems to understand not just objects, but relationships, movement, intent, and consequence in space?
So, sure that the broader the data stream, the more concise and semantically correct. And that is what we've done, the homework to have clear semantics on data and clear data format. Is an important data stream, and we can see it also in our day-to-day world. If you watch a soccer game or another sports game, you see humans that know where is the other player and how they behave. They have certain tactics. They move coordinated. So they have some, or we as humans have some understanding what means next to each other, what is mean, and we can anticipate what might happen next. That is all location data and moving in space. And that is what we can teach machines by GPos and companion specification.
Okay, so thank you for differentiating all of those different terms. I wanted to summarize this real quick before we move on for the audience. And as you can see here on the screen, RTLS tells us where something is. Spatial intelligence then tells us what that means operationally. And physical AI uses that understanding to decide what should happen next. And so we are going to move on. You guys have all talked about machine and spatial semantics converging. Now, how is this actually achieved with standards? Stefan, perhaps you can start with the OPC UA semantic layer.
Yeah, as mentioned, OPC UA is more a tool. Let's call it like the Swiss knife, right? And you have a lot of functionalities to describe something, to describe and agree on semantic. So what does it mean if Bethany, if I point to something and say, hey, look, this nice jaguar, you might think on the animal because you are in the zoo right now, and I'm at the street looking to the car. So we humans are using our context information automatically, our brain, to figure out what is the meaning of the word. But this is not what machines can do, right? A robot doesn't have eyes. Is he located in a zoo or on the highway? So we need a precise description of something, of the jaguar. What do we mean? And we all have to agree on this worldwide, or at least in this specific market. And this is not only on the position, it's also on basic fundamental topics like the temperature, and if we are in different regions in the world, we need metadata to describe the temperature. Like, is it Fahrenheit or Celsius, right? So this is where exactly experts of the world come together to say, let's agree on the semantic to describe whatever, the robot, that we have only one description of the robot or one description of the auto ID device, but being able to understand multiple source information of specific sensor signals like the 1D or 2D barcodes or whatever. So this is a fundamental what we need first for the digitalization of the world. I believe this is really the key, agreeing on the semantic. And that's exactly what Matthias already mentioned. The better semantic you have, well described, the better AI can work with this also automatically. And now back to the position here. We mentioned already a mobile HGV somewhere, but just think about an analyzer device staying on a table in a lab, in a laboratory. Now you think, why do we need the position of this one? Well, because just as an example, automation, the industrial automation world is much more growing into this laboratory world to work 24/7. Remember the pandemic, and we have not been able to do enough tests within the time, and it took some time to figure out, am I tested positive or not? The labs are heavily under pressure to get higher automation level. And so now a mobile robot, a cobot, is working in front of these devices and exactly need to know where is it that these devices can talk automatically to each other. And so they have to agree on the same understanding of the position here in this case, right? So semantic is the key for the digitalization of the world.
And I wanted to go a little bit deeper into that. How are coordinate systems and transformations represented?
There, I might jump in as I'm more expert on the geospatial side. So of course we all know we live on a planet which has a certain shape. It's like a ball or something like that. But when we move indoors, things become rectangular, things become flat, and so we have to. And quite often, then we know only the position relative to a certain point. So it's 1 meter to the left and 2 meter to north or to a certain direction. And the challenge is to compute local coordinates within buildings or in a mining site or in a hospital to global ones to allow you to track things holistically indoors and outdoors. And this shift is also necessary to generate a stream of seamless data as said for AI systems and to allow you to build those interconnected scenarios. So there you have quite often a local frame within a building and the global frame or the global coordinate systems that covers the complete globe.
And you mentioned the local and global frames. How do those coexist?
That's part of the specification, how you can compute from local to global. That is part of the companion specification, how you do that so that everybody does it the same manner or in the same way so that the data is transformed similar. And yeah, so that is part of the companion specification that we have done to describe exactly how to compute from indoor coordinates to outdoors or vice versa, so that everybody who is providing the data is doing it the same way.
And then another question that I wanted to ask is, how do you model moving and fixed assets consistently?
Yeah, that depends on the general system architecture. In OPC, you have a lot of companion specifications like the laboratory devices or other fixed machinery that have a certain stationary position that might just feed a sensor value at a certain position, temperature at a certain area of the room. And then you have other elements that are moving and that, as I said, move to this laboratory device, like Stefan mentioned in the example. And that is something that we are concerned with in Omlox, how to deal with all this kind of movement, how to compute the different elements. That is something that members who implement the Omlox standard then have this computing software that does all this and then feeds it to OPC, for example.
So then how does this complement Omlox?
The GPos is, in a nutshell, the additional semantic layer for patient data that an Omlox system might generate. Then it's into OPC foundation and in an OPC server. It provides then additional data stream in coexistence to all the other sensor data or machine data or data streams. And by that, you have the semantics of machine data and information and the location semantics coming from, for example, an Omlox-based system. And those two elements work nicely together and you have interoperability between different standards.
And so then before we move on from the Omlox and real deployment side, where do you see the biggest operational value once these semantics are unified?
We in Omlox are mostly at given point in time, a lot of is going on in automated materials, transition from forklift to mobile robots, and then the material flow from indoors, from the yard, truck is arriving, and then material is moved into the warehouse, from the warehouse to the shop floor, and vice versa. So this material flow, there is a lot of emphasis these days. We have all these supply chain disruptions. We have all the dynamics in geopolitics, and a lot of companies are trying to automate this kind of workflow. And then, of course, they touch these systems to identify what was on the truck, what is moved indoors. And then they have the machine data for this part has now arrived at the machine. It should now be processed to a certain product. So the interconnection material flow, that is the hottest topic in industry, but we see it also in other verticals. Healthcare, for example, is a huge topic. Automation takes place to streamline healthcare, for example, or Stefan mentioned already also laboratory processes.
Thank you. And before we move on, just to summarize all of this, from what I'm hearing, the real breakthrough is that machine telemetry and spatial reality become one computable system state. So now I want to transition the conversation from standards to operations. Could each of you share one example where unified spatial semantics materially changes what a factory, warehouse, or robotics fleet can do?
Yeah, sure.
I could, Olaf, yeah, go ahead.
Who wants to jump in? Yeah, it was that quiet time frame there. Well, yeah, for sure. I mean, one we have already here on the picture here. As soon as you are in a logistics center, you will find nowadays these AGVs, maybe in cooperation or interaction with a robot, but often, of course, with humans, so that humans will load the AGVs. And of course, the AGV needs to know where to go, where to find the right location in the warehouse. On the other hand, as well, it needs to know what kind of item is on top. So here you can see already that is, I guess, a very well as well nicely visualized here on the screen, an example what we can see nowadays everywhere when we're coming into logistics scenario.
I would like to add on this point. In independently from logistic efficiency and benefits for logistical systems. Here is a very important point is to focus also on human security, human safety. So if we have robots together on a workspace with humans, always humans need to be first. And that humans can be first needs a very strong global positioning system, either an absolute system or a relative system. So this is also a very important point, not only the efficiency of industrial and logistical processes.
Another use case, what one can see quite strong in media, using AI to plan and simulate production sites, using the speed of AI to optimize production sites, logistics sites. But of course, that is the design and planning phase that can be speed up. Of course, then at some point in time, the thing got built, and then you need to have a feedback cycle. Is the operation really working as simulated? And we all know reality is a different story than a digital one. Therefore, then you can use this location data to feed in again this planning and simulation cycle, and by that, use this data stream to optimize in a iterative cycle operation. That's something that we can see these days.
Matthias, if you say it is also with simulation, is this also leading into digital twins of something?
Exactly. That is, digital twin is a broad term, but yeah, of course, that is some notion of a digital twin on a bigger scale. So it's not a digital twin of a single product, but rather a digital twin of a logistics site or site, another facility where I say, I use AI to design my next production site at some place, and then I use location data to, once it is built, to optimize operation. Yeah, that is.
No, yeah, I can't agree more, because if you have a full semantic model of something plus the behavior of something, then you can just create another instance, which is no longer the physical asset. It is somewhere running in the edge or even in the cloud. And then you do not have to upload all data in every cycle. For example, for a robot with multiple thousand data types, it doesn't make any sense. But you can select what kind of data you want to have in the digital twin, and yeah, so that's where I believe exactly this fundamental technology gives all the power to have these. I mean, when we talk about these examples, I already mentioned this with laboratory stuff and robots working in front. Real world examples are also AI. Matthias mentioned that before. So yeah, we are just summarizing here what we have spoken already a little bit about before, right?
Thank you all for those examples. And what I'm hearing from this is that this moves us from isolated automation islands towards true orchestration across machines, robots, people, and process flows. So moving on, a question that I wanted to bring up is, why is this becoming such a strategic priority right now? What do you think is driving this? Is it mainly robotics density, labor shortages, supply chain volatility, or the rise of AI agents? And Olaf, can you start from the market side?
Well, that's a good question. What is really rising it? What I like to mention again, and we already mentioned it before, but first of all, we need to understand that Auto ID, RTLS, and of course also OPC UA, everything what we have spoken about here mainly is a kind of core technology. It's a kind of base technology. So that means if you like to create these new solutions or these solutions, we see right now when we are talking about AI, it's important that you have a clear semantic, that you have a clear description of these core technologies, so that you can seamlessly integrate those base technologies. Because without, and this we have mentioned also, without a clear, good semantic, the AI is not able to do the magic, as good as we would like to see it. So that's again a core feature. So we need to make sure that the the base technology can be used as easy as possible, and that these are really good, described very well with a good semantic, so that in the end you can use it in an efficient way to make sure that the AI works as efficient as possible. We have seen this also at the last Hannover Hannover exhibition, where we've seen a lot of robots, and I guess it was a kind of key point here to show what's possible when it comes to human robots. So again, the RTLS, AutoID, OPC UA, everything is a core technology, is a base technology, and we need to make sure that's really seamlessly integrated by good semantic. So the description in a semantic way is very important. Because of this, standardized solutions are getting more and more important. Yeah, it's really a core that we have a clear standardized way to provide, to make sure that it's vendor independent, technology independent, so that's not a single solution driven by one single vendor, to make sure that the core technologies can really be used in every solution in an efficient way. Yeah, by this, of course, and this is of course driven by the worldwide industry. Yeah, standardized solutions are not driven by a single vendor, are not driven by a single industry. So typically, as you could see here, we have a collaboration of 3 different associations, and that's the reason for it. Because when we're really talking about standardization, it makes sense to have a wider angle, different kind of needs, different kind of focuses, and bring all of this under one umbrella to make sure that you have a good standardized solution later on. Yeah, and so that was as well the motivation for the global positioning, and as already mentioned earlier by Matthias as well, how we started with this, with the use cases, to find use cases first, to think about how to standardize this, what needs to be standardized, and so on. So this was really the core, and to make sure that in the end, especially global positioning and can be used efficiently, because it's now standardized. And I guess this is a major goal, to make sure that the rest can be based on it.
And Matthias, I wanted to switch the conversation to you. Do you see customers increasingly asking not just for visibility, but for autonomous decision layers on top?
Actually, these days, many companies are asking for that, but quite often don't have the data layer to have good results. And then they deploy AI systems and wonder why outcome is not reliable enough, because they might start with a second step before the first step. It would be using OPC UA, using Omlogs, using ID technology, have a streamlined data stream, and have first visibility, and then based on the data that they collect, then automate decisions either on a intelligence layer like described with geofencing, collision handling, or already jumping to the next step and using AI to automate even further. So, but often the data layer or companies try to switch the groundwork on the data and then wonder why the results are not good enough. So first do the homework, use the standards that are out there, and then build on top of that. Otherwise, you might build the roof before the basement, and that doesn't work.
Thank you. And Stefan, before we move on, how critical is open standardization to prevent the next generation of AI from becoming fragmented again?
Hey, I'm answering in a second. I just want to second here what Matthias mentioned. Analysts reported us that mostly companies, when they start on, oh, let's do something with AI, they do a proof of concept, which normally has a length of about 3 months. And the first 2 months they're just losing by preparing, learning about data, and finding mathematical algorithms on patterns in this data. But analysts also figured out, if you have strong semantic defined, for example, with OPC companion specifications, you can start from day 1 and you are productive. This kind of productivity is exactly what Matthias mentioned. where if you have good data coming in, then AI is super efficient. And obviously, to your question, Bethany, we need again have one understanding in the global world that AI should have same results independent if this is happening in US, Europe, or Asia regions in the world. And this is happening already. It is not academic for the future. It's something companies are working and using AI already. And we have that feedbacks already in public available success stories. And so that's why the OPC Foundation, by the way, started another AI initiative. And they decided already that all companion specifications, including what we are talking here today on, will be converted even in a more AI-friendly REC standard readable AI format. That also MCP servers are using. So it's another tool that you tell the MCP, okay, you will find an OPC UA server, and that's about global positioning. And then you can just talk to AI. Hey, all the examples we mentioned. Tell the robot to move to this machine and grab the package. And that's it. You don't have to do anything more, and the rest is done by magic, right? But AI is only able to do this because of this fundamental work what the gentlemen have done here, right? And that's why Olaf, I'm adding a little bit for your statement on what is SAMI on all these associations cooperating here. What I believe really also makes me really proud is that all of these associations here on this call are non-profit, and they're getting zero research money. So everything what we do is industry driven. This is important because otherwise it has no relevance. This is why we do it, right? Because of the demand of the industry behind. And that makes me really proud because we see adoption, and so all the work and all the efforts and personal passion behind is really leading into adoption in the world. Yeah.
I would like to add, Bethany, your question about open standardization. Is it able to prevent a fragmented AI in the future? I guess the answer is already part of your question. If there is one thing which is able to prevent this fragmentation again, then it is standardization. And standardization is always open. Otherwise, it would not be standardization. Yeah.
Thank you for that. And then looking ahead 3 to 5 years, and we are running out of time. So quickly, what becomes possible once machine data is natively understood in space, and what excites each of you the most?
For me, all the agentic approaches, I built the first agentic systems 20 years ago, and to see them really coming to production and talk to machines and the language models and the data coming from Omlogs, from AIM. Quite exciting to see all the automation going on.
Yeah, so I can just contribute this. Yeah, I guess this will be really interesting. So as you have learned or heard during our speech here, our conversation, yeah. So we are believing in standardization. We started already decades ago, and this is one of the aim as well of the AIM Association, also of Omlogs and OPC Foundation, of course. So it will be very good to see that everything fits together. Yeah, for sure. We have to tune a little bit in the future. We learn more and more, of course, by the time. But I'm really excited to see where it will lead us, as well as the technology is now available. I mean, we have the capabilities to do all these, autonomous things. Yeah, and that's really cool to see. It's going step by step in a kind of right direction. Yeah.
Thank you guys for that. And We will move on to, I think we'll only have time to get to only 1 or 2 questions today, our Q&A session, but thank you guys for your presentation on that. This question we just got here is, thank you for the presentation. I steward open source middleware for IoT and RTLS, and it is currently OPC UA capable for telemetry. I just browsed the global positioning v1.0.0 spec, which I would be happy to implement. Question, how can one best test to ensure that any implementation is indeed correct?
Typically, that's ensured by the OPC Foundation and testing
Yeah.
procedure, so that
I have two answers on this. Right. Thanks, Matthias. So the OPC Foundation provides a tool called the CDT tool, and well, this is now a teaser. So next week we are announcing a CDT Lite product, even. Which is so the CDT full is having 2,000 test cases if you implemented OPC UA correctly, right? And the person who answered did the question is maybe knowing about this, and you get it as a member, but even as a non-member, you can get it for super small money. But next week we are announcing a CDT Lite tool, which does not have these 2,000 tests, but you can load information models and just figure out, does my asset has the information model loaded? Are all the variables at the correct place with the correct data type? Which is a first test of the semantic. It does not mean that this is a full test of the functionality, because that's much more to do. But at least this is a great first step, and this also allows you, if you are an end user and you get a device from somebody, that you can quickly test, is this device following the specifications. My last hint is, if you're an end user, always ask for certified products, or this will definitely help you to immediately get a quicker ramp up.
All right, and I think that we will have to move on because we are running out of time. But if you have any more questions for our speakers, you can reach out to them through the information listed on the screen. I'm sure they would be happy to answer any questions that you may have. If you would like to reach out to AIM, you can do that as well through the information listed on the screen. And Peter, for everyone listening today who wants to be part of shaping this future, can you let the audience know how they can get involved?
Yeah, for sure. Thank you, Bethany. So the best way is just to join the Global Positioning Group, and whatever we create out of this in the future, this means we can inform you via AIM or Omlogs or OPC Foundation. I guess the easiest way is to contact either AIM Global or AIM Germany, and then we will coordinate all questions and all future agenda for all people who are interested. And maybe an additional remark, Stefan already mentioned that it is non-for-profit. So whoever is interested in working on the future of global positioning, it's a working group, it's not a taking group. And so we invite everybody who wants to deal with us. So just say hello, and we are open for everybody. Thank you.
Thank you for that, Peter. And thank you to Matthias and Stefan and Olaf for today's presentation. And thank you guys for your questions. And thank you all for joining us today.
Yes, thank you for listening. Thank you very much.
Thanks.
Bye-bye, everybody.
Bye-bye.